Okay, it seems that you can hear me. Awesome. Okay, cool. Where are we? Okay. This is lecture 8. I think it's lecture 8. I'm losing track of what week it is. And it's about raster data analysis. And I thought I'd sort of mix it up a bit. And so your second assignment, which we sort of did a bit of preliminary last week. So I wanted to actually explain some of the things and just chat about some of the stuff with the sort of work that's done. So it's more like a case study, which is quite interesting. Well, I find it interesting. So I hope you do too. So Griffith University would like to acknowledge the people who are the traditional custodians of the land, pay respect to the elders past and present, and extend that respect to other Aboriginal and Torres Strait Islander peoples. So this is it's gonna describe, it's not really a proposed research study, it's something I actually wouldn't mind doing, something similar, and I know people are already doing this, but just to show how raster data is used in environmental science, specifically how to measure vegetation loss post climate change exacerbated bushfires. Well, that's a bit clunky, that sentence, Heather. Okay, anyway, so it's been raining for about a year, and we've probably we've had a lot happen in the last 2 years plus, but I'm sure the bushfires of a couple of years ago are quite, I don't know, upfront in people's minds, definitely where I am, because I'm looking out my window and I can see bushland. I don't know how far it is from my house, definitely closer than 15 meters. Yes, it was quite traumatic, I found, in 2019, late 2019, early 2020. And then, of course, we had COVID. So everyone forgot about it and it started raining, but almost certainly bushfires will be back. So the increased number and severity of bushfires are one of the most important risks of climate change, particularly for Australia, which is the driest continent in the world. In fact, I think it was Michael Mann, who's one of the preeminent climate scientists in the world. He said Australia is like the canary in the coal mine because we are subject to so many different types of natural disasters from climate change. I mean, there's the bushfires, there's floods, there's cyclones. We don't really get tornadoes. But yeah, so Australia has a lot: drought, all the different things that which are exacerbated by climate change, reductions in fresh water, etc., etc., etc. Australia is a very good case study. So Southeast Queensland, until recently, particularly what's known as the Gondwana World Heritage Area, but the rainforest areas weren't considered high risk for bushfire. In fact, like where I live, I've got outside my house is rainforest, and I never really was particularly concerned about bushfire because it's all things like Piccabeen palm, aka Bangalore palms, what's their name? Ocontophoenix Cunninghami. I think there was some botanist in the early years called Cunningham, because there's an awful lot of things that are called Cunninghami, like Araucaria Cunninghami and all sorts of different things. Anyway, so unlike eucalypt and other fire-adapted species, rainforests are not fire-adapted. If rainforests burn, they tend to music is detected and may be suppressed. No, I'm not playing any music, you silly thing, team. Sorry. My teams told me to detected some music, and I can detect a cat, but I can't detect any music. Maybe it was my phone's. Anyway, so yeah, when once rainforest burns, it pretty much sort of stays dead, and what happens is then replaced by, species which are more fire adapted, like eucalypts, for example. But even fire adapted species like heathland species or eucalypts, etc., if they burnt too often, then they die. So this all changed in late 2019, early 2020. And bear in mind, I'm specifically speaking about southeast Queensland. I mean, northern New South Wales, prior to the bushfires up around, just trying to think where it was, northern New South Wales, inland of northern New South Wales, there was some quite severe fires in the rainforest areas, as they were up north. Anyway, so it's quite worrying, and bushfires are really bad. And of course, bushfires exacerbate, and they're a multiplier of climate change because they put more carbon dioxide into the atmosphere. And trees absorb carbon dioxide, not to the extent that some dodgy politicians have tried to argue. But anyway, you can plant as many trees as you like, and unless you stop emissions. Anyway, so so this was a map and a project that was done. It was actually during the bushfires, I particularly remember being incredibly stressed because I love Binnaburra. It's very close to my house, and I love to go walking there. And I particularly love the Antarctic beach. Oh, Notophagus? Is it Cunningham? I think they changed the name recently. Anyway, I can't remember. So so you can see there, this is a type of remote sensing satellite that Dr. Patrick Norman used to map some of the fire spots. Sentinel-2 and something called VIIRS, which I don't actually know what it stands for. So that's the park boundary from Lamington National Park, and he overlaid the walking tracks just so I could get, he actually did it for me. I could do it as well, but it was his work. So he overlaid some of the walking tracks around Binnaburra to give some sort of idea of where the fires burned. Is that ship's stern? Not too sure. Anyway, so I should have labeled them. But so there is rainforest there. So you can see rainforest, and the walking tracks and the park boundary. So you can see there was quite severe fires, and particularly spot fires all over there. I've got friends who live up there in Saraba, which is his study area, and they were evacuated twice. Luckily, they didn't have any damage. They lived on big acreage, but still, she had to move all the horses and everything. So as I said, rainforests are not fire adapted. The Gondwana, also the Gondwana World Heritage Area, runs along the Great Dividing Range in New South Wales and Queensland. You can see that's just a sort of screenshot there from the Queensland World Heritage Site. All along there. That's sort of where we are there. That's not too sure where that is at Nightcap, not too sure. And there around Armidale, inland from there, and then down along there. So it comprises the main, that's a quote, bad grammar. It comprises the major remaining area of rainforest in southeast Queensland and northern New South Wales. And it's outstanding examples of major stages of the Earth's evolutionary history, ongoing geological and biological process, and exceptional biological diversity. And these are restricted largely or entirely to Gondwana rainforests, and these are the principal habitat for many threatened species of plants and animals. And one of the most worrying things about impacts on this sort of environment is there's sort of what's called refugia. If you go up into, Riley's is probably about, I don't know, 1,000 meters above sea level. Binnaburra is slightly lower, 700-800, I think, offhand. Tamarind Mountain, where I am now, is 525. And if there is a large mountain range and there's things which are adapted to a specific altitude, well, theoretically, even not in this space of climate change, entire ecosystems can move uphill, which in reality they won't. But I mean, where's a Antarctic beach community? Those groves of Antarctic beach can be up to 20,000 years old. Where they're going to go? It's the height, the top of the mountain. Anyway, it's very worrying and depressing. And yeah, okay. And of course, all the many threatened species of plants and animals. And I wrote, I mean, this is just a quote, but obviously there's fungi and insects and all sorts of other different things. And of course, many of which are completely unknown to science that we might be killing off. We don't even know what we're doing. Anyway, no comment. So yes, so I mean, obviously, rainforests are they're stressed with fires. Fires can kill them, and it's raining now, so the rainforest's happy. But I can see outside some cyathea, some they're common yuccas, lots of picabeen/bangalow palms. And there's a picture. I think I took that. So yeah, I did. So this is a Antarctic beech grove, and Antarctic beech are really interesting. If any of you have done biogeography, and it's when Gondwana land split up, Antarctic beech is found on most of the southern hemisphere continents except southern Africa. well, seeds and relics of it. And that means Southern Africa split off before the rest of the continents sort of split up as they were. But they've even found, I think, and please correct me if I'm incorrect. I'm going back to what I did in honours, which was a bit of a while back. Actually, it wasn't that long ago. Yeah, it was. Okay, so yes, in the Antarctic beach, and they're absolutely beautiful, and it's misty, and that's the sort of environment. But that's like the top of the mountain, pretty much. That's Binabara. It's the one of the tracks, one of the short tracks up there. And this is one of the maps I got off, not too sure, probably Queensland Parks and Wildlife. It says wildfire area on QPWS, on QPWS estate, and there's Lamington National Park. Where's that? Border Ranges, Main Range National Park, Mount Barney. Last weekend I went to Girraween, which is sort of over there to the left, to try and escape the rain, and it rained there too. Anyway. I was very sensible. I was going to go up a dear little granite mountain called Mount Norman, which I'm very fond of, and it was slippery, and I was sensible, and I decided not to climb it. Otherwise, I might not be here today. I did say to someone who I encountered, I said, I recommend you don't climb it because it's quite slippery, but I said, it did have good mobile reception. So if it fell off it, you could ring 000, or at least when they found the poor pathetic, stupid middle-aged person at the bottom. Anyway, no comment. Oh, sorry. Can anyone else hardly hear me? I can turn up my volume. Can anyone else? Oh, good. Okay, cool. Maybe Mohammed, you need to check your own sound settings if you can hear me, because I don't want to actually put my volume too high, because then the recording is horrendously loud and it stuffs up the quality. So yeah, Mohammed, please check your sound settings or your internet settings. Okay, cool. Anyway, so there is like our study area, as you'll see in the thing, in the workshops and that's where it was burnt in Lamington National Park. And the study area I've given you sort of intersects a bit of that. I tried to choose an area that had a combination of farmland, national park, and all sorts of different things, just because it's actually quite hard to do vegetation analysis from remote sensing data just on rainforest, because from the air, you can do it, but it's very complicated. It needs a lot of field work, which would be awesome, but that's not actually what I'm teaching you in GIS. And there's plenty of people at Griffith who can teach you that really well, which is not me. So rainforest intensive wildfires outside planned burn guidelines are potential threats, and the impact of fires is a significant concern for World Heritage values. About 46% of the Queensland section of the property was impacted, and this included 6,861 hectares of rainforests, and up to 1,600 of Araucaria cunninghamii, which is the Araucaria species are incredibly. Oh, there's another Cunningham. You see, it's not Araucaria cunninghamii. This is the bunyip palm or something. Anyway, anyone? I know what it is. But it's Araucaria species are particularly interesting because they are relics of forever ago, blah, blah, blah. Anyway, that's horrendously not very scientific words. And extensive areas of eucalypt woodlands and forests were severely impacted. And this is likely to impact a range of relic, endemic, disconnected, primitive, rare and threatened species. The Queensland government continues its work with the Australian government on bushfire impact assessment. I think DES is still called DES. That's very unusual for a Queensland State Government Department. They've had the same name for at least 3 years now. Sorry, I'm being snarky. So fire mapping is either dynamic, in real time, used for emergency services like firefighting, evacuations, etc., or static, used for researching fires after they happened. So there's a lot of stuff, if you look at ArcGIS online, and a lot of actually things is you can actually see real-time fires. And so both types of mapping use satellite data, but there's various different types of satellite data, and they measure different parts of the electromagnetic spectrum. And I'm going to play you a video you've got time. Yeah, no problem. And this is generally accessed from the various different types of satellites, such as Landsat, Sentinel, VIIRS, or other satellites. And you can actually access them from the NASA thermal hotspot layer. Now, I crashed my ArcGIS Pro over the weekend because I was trying to import a 64 gigabyte thing from OpenStreetMap. No comment. Anyway, and after like 17 hours, I decided to, because it was saving it in some temporary thing, and then I got this terrible warning saying my C drive had no more space in it, which was very worrying. So I crashed it anyway. So my ArcGIS hopefully is working enough by the online tutorial today. Also, as I said in the announcement, the online tutorial is half an hour later. Sorry, I've got a really important meeting that finishes at 11:30 and I can't get out of it. So there's some online fire maps. Here's one here. It's horrible base maps, and on Queensland Globe. You can actually find it on Queensland Globe, but good luck trying to find it. It takes some sort of navigation or Googling to get it. And Queensland Globe was getting very dodgy last week. It was sort of hanging and it wasn't loading things properly. But anyway. So there's one of the things that you can get, for example, from ArcGIS Online. That's thermal hotspots. And that's another one there. So you can get those from ArcGIS Online, and that was one, I don't know what date that is, I was using it as an example. So that's acreage of burnt areas in California, by the looks of it, Northern California, which is particularly prone to bushfires. And they're having a giant drought, I think further south in the United States. Apologies to all Americans. Yes, anyway, there's just too much news around. Anyway, so there's the other one, the burnt areas by state, and I've actually given you a layer of this for your project. And this was actually T3's project, but you can see I used some of the similar data. And there's some of the various things that you can get with bushfires. It's just it's not very a big web thing that at all. So yeah, let me just check how many things, because I want to play you a video, but I don't want to hits. Okay, cool. Plenty of space. Okay, cool. So question on the assignment. So did the 2019-2020 have a lasting impact on the forest vegetation committees? So communities, committees. Sorry. So what were the vegetation types? Now, bear in mind, the work I've given you for the assignment is very, very, very broad. Okay, so like if you're going to do a really proper project on this, it's much more comprehensive, and it'll probably be like a PhD project. So just a broad question, what were the vegetation types in a specific area before, during, and after the bushfires, and how much of each type burned in the bushfires, and how much vegetation recovery has taken place, and was it of the same vegetation type? Now, when I say vegetation type, I'm not looking at the specific, things like in the Vegetation Management Act and all that sort of stuff. It's rainforest or grassland or eucalypts, because this is an undergraduate assignment, and to do this comprehensively, and people have done it anyway. So let's see how there's various ways you can go about doing it. Now, one of the things that's really interesting is a project I found called the Google Earth Engine Burnt Area Map, GBAM. And if any of you are interested, now we are going to be running a T2 course, which I'm going to be convening, and I'm going to be looking at a lot of spatial data stuff using Google Earth and Queensland Globe and ArcGIS Online. It's supposed to be actually a preliminary for this course next year, but if anyone's interested, it's 1024 ENG, so you can enroll online if you've got any time in T2. So a Google Earth Engine Burnt Area Map, oh God, these acronyms, GBAM, let's just think of GBAM, I think it sounds like a suburb of Brisbane. A rapid national approach to fire severity mapping. So the results were used to quantify the potential impacts on wildlife, plants, and ecological communities. And the DPIE, one of the Remote Sensing and Landscape Science branch, developed the Australian Google Engine, and the data set uses Sentinel-2 satellite imagery. And the imagery I've given you for your project is from Sentinel-2 satellites from before and after the fire. Now, this was much more comprehensive. The report is there. It's really interesting. It's quite long, but it's understandable, and it's really interesting. And it presented 4 fire severity classes for the areas represented on the National Indicative Aggregated Fire Index. Oh, they love their acronyms, don't they? Anyway, so this is the report there, the link there. It's really interesting if you want to look at it and if you're interested in the subject. Ew, stuff that up. I suppose I could fix it. Go off. I'll fix it for the uploaded one. So let's just go. I'm going to go back onto my lecture. What did I say there? I'm just going to sort of like, I changed the layout of this. There we go. I can do it in real time. Good. So the exemplar method, they used the National Vegetation Information Systems, which you can actually download off the internet. It's quite big. It's a couple of gigabytes. But you can clip it to Southeast Queensland or Gold Coast or where. Well, our study area is actually in Scenic Rim mostly. And they use the interim biogeographic regionalisation for Australia and the Sentinel S2 service reflective from Copernicus Hub. Now, I showed last week some of the things that you can get from Copernicus, and you can get these awesome. I mean, Copernicus is absolutely awesome. Now, Chris is the expert on remote sensing, but I've become more and more interested in it since I started teaching this course. I mean, I did a bit of it before, but I mean, this is like so cool. And I like, you know, I love research and I love sort of projects and stuff. And I really, I don't know, it's just so cool. And there's just so much really innovative and awesomely, incredibly interesting stuff. Okay, so particularly around big data and things like this and satellite imagery. So what they did is that in New South Wales and Victoria, but they did for, you know, the whole country. So they used image processing, and then they calibrated with visual interpretation of remote sensing, and they classified severity classes using random forests / random trees, which is the algorithm that we're going to use in the project. We can use any of them, but I like that one best. And validation based on ground data where available. Now, if you're going to do this sort of stuff, you actually do need to validate it. So quite often you do what's called training your data. So you have a training data set, and this is to do with things like neural networks and remote sensing, and you put all your data into your algorithm and your model, and then you run the computer thing, and then it trains it and it redoes it until it gets to a result that is close to reality. And in the workshop, in the online workshop, I'm going to show you how to do some of that sort of stuff. Well, the computer does it also, it's easy. Okay. And then the image processed through Google Earth Engine, and then to classify the severity classes, calibrate and validation. So it was really interesting. So I do really recommend that you actually download this thing because it's fascinating. So this is the GBAM, how it worked out. Go back into my lecture, move it up so I can see. I'm doing this in real time. Lovely. Okay, there we go. So it used fire severity field points to evaluate the accuracy of the model, and it created 5 classes: unused / non-native, unburnt, low and moderate, high, and very high. And you can actually go onto ArcGIS Pro and you can look at GBAM. I'm going to try and open ArcGIS Pro in the background and see if I can sort of just show you in real time what GBAM looks like. That is assuming that my ArcGIS Pro is now working because of my attempt to get a vast data set from OpenStreetMap. Now, the reason I was doing that, and I'll actually show you in real time because it's like interesting, and whilst it's thinking. So, and then it also reclassified a burn index from ordinal. Now this is, I'm going to turn this off, but if I chuck in like analysis and I go add data and I just look into check it on ArcGIS Line and just look up. Sometimes ArcGIS and Line is a bit temperamental with finding stuff. There we go. I can find it this way. And if I pop GBAM on, it'll take a bit of a while to load. Yeah, the reason I actually was trying to download is you can get the layers from OpenStreetMap with a plugin through QGIS or ArcGIS. But if you want the exact more detailed one, it's bizarrely done by Facebook of all people, with the actual things like building footprints, which I was doing for another project. There's a data set called, if anyone's in OpenStreetMap, there's a data set called Daylight. It takes a bit of a while to load this. Thinking about it. Okay, so I'll leave it in the background until I'm going to drag my ArcGIS down there, and when it loads I will I will wait for it to come on. Okay, so it created 5. It's taking a bit of a while to load because it's got this, giant, it's anything with ArcGIS online, particularly up here. It's on Tambourine Mountain when it rains because the council never fixes the road. Then I don't know, I think the NBN pit gets wet. Okay, you can actually get it from ArcGIS on. Anyway, I was trying to get building footprints from this daylight, and you can normally get OSM data, OpenStreetMap, for individual countries, but for some reason you could only do the whole world. And believe me, there's quite a lot of OpenStreetMap data for the whole world. Anyway, I crashed ArcGIS doing it. So don't worry if you ever crashed ArcGIS trying to find data, because I crash mine all the time. And the more you do things, the better you get at it. Okay, so a method one could do it. We could collect relevant data sets and other vegetation mapping, fire scar data, satellite imagery. Now, ideally, when you're doing any sort of research project, you need to sort of look at the same month and same time. So it's not much point, say, for example, looking at a data set from a dry part, say like August, and compare it to a very wet time of year, which is, let's say, like March or May, as it may happen. So a way you could do it is similar to what I've done in the project, a small area. You can see the vegetation type mapping corresponds to any of the years above. Feel free to try and do that, but you need to look at the metadata for the vegetation mapping and make sure that it's from the same year. So even though my specific data sets don't have metadata, they're all from Queensland Spatial Catalogue, and you can find the data set and look at the metadata and see it when it was mapped. So if you, for example, you don't have to do it, it's optional. But that's the sort of stuff that you might do for, if you're going to do a comprehensive report or project. And you can overlay the vegetation hazard class, the slope, the digital elevation model, anything like that. Another thing you can do is digitize vector vegetation types against the satellite imagery. To be honest, I actually tried that and I never actually got it to work, but there's various different things you can do. So this is not what you actually have to do, but there's ways that you can actually look at it if you want to do something comprehensively in this. And to use base year satellite imagery, classify vegetation using spatial indices, which we're going to talk about next week, image classification of the data sets, and calculate vegetation loss type and area vegetation recovery. Now, obviously, this project that we're doing is way, way, way less comprehensive than this, but there's various things that you could do sort of to a high level. Now, let's just go on to this. So there, for example, this is what I do, for example, is when I do a GIS project, I normally start doing a table. And my table would have what data set I want to use. So there, for example, there, what I've done. So this is just various things, what one might do. And then the source where you get it. So these projects, you don't necessarily have to do that, but you can do it in your report for assignment 2. Yeah, it's good. And I tend to write a list of what data sets I use. So I've given you lots of data sets. You wouldn't want to use all of them, and some of them are the same anyway. But you might write, say, for example, the first 4 data sets you use, and then you might say what you did to it. And for example, so that's actually really good. And I say table 1, sources of data used in project. And I would do that in any GIS report, and also keep a, when I do any sort of geoprocessing thing, I tend to sort of start with dot points of the method that I use. And that's what stands you in good stead when you're doing any sort of project. Okay, so what we want to do is that satellite data uses the electromagnetic spectrum. And those of you who are studying science, I'm just trying to find my video. It's in the next slide. Okay, so I'm actually going to stop sharing after this slide, and I'm going to start sharing again because I think you meant to say make sound work. Anyway, so the satellites use remote sensing to get information, which is then put in the rasters about the Earth. And the electromagnetic spectrum is the entire range of light that exists. The GBAM was not showing on the map. Oh, how annoying. Okay, never mind, we won't show it. But, when you look at a raster, it says red, green, blue, etc. But rasters have lots and lots of different information. And I'm going to show you a quick video because it is relevant. And I'm just going to quickly stop sharing just because I think you've got to say, put sound on. So I'm going to go to the next one. And then I'm going to share again. So let's just click share, and there's a little thing. Include computer sound. I don't know why they don't just make this default. Okay, so I'm going to include the computer sound, and I'm going to go into the next slide and play the video. It's very short.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our Sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
Oops. No, it's starting. Okay, cool. Okay, well, this is like, I mean, the reason I'm showing that is because satellite imagery, remote sensing imagery is pretty much, that's how it uses. It doesn't just use visible light. So something like the Copernicus satellites, the Sentinel-2 satellites, check it doesn't stuff up my, I'm going to do a rubric for the assignment and it's just driving me nuts because it's so clunky. So the Copernicus satellites use various different types of parts of the electromagnetic, the EM radiation to calculate different things, and different things like, so for example, this fire imagery and stuff like that. So it all uses different things, and we can only see certain of it, and it's got different spatial resolution, it's got different bands, and that's how they sort of, and that's how you look at the things. So if you go, for example, I'm going to actually just put this into the background. I think where's my Sentinel? We'll just do this one. We'll chuck him up here. We'll chuck him up here. So there's my Sentinel. And if we go into the browser, you can discover the various different things and the different, so there's the different satellites, for example. And if you want to do a theme, theme do we want on monitoring Earth from space, we'll do just search something for today around Rome, so it doesn't really matter. Let's have a look. It was very cloudy in Rome too. There's one that's got no clouds. And if I just click on any one of these, for example, you can see that uses the different bands of the Sentinel-2 satellite. It's a bit cloudy. But if I look, for example, and you go to the drop-down list here for the false color, it's a false color composite that uses at least one non-visible wavelength to image Earth. The false color composite using near infrared, let's go somewhere where you can see, red and green bands is very popular. So, for example, there's one with, looking at that sort of stuff. You can go on to a theme here if you go further up. It's a bit clunky sometimes to find things, but you can actually look at this, the moisture index, how dry is it in Italy at the moment? Don't know, not really. You can do scene classification. So this is how it uses remote sensing imagery. I'm just going to go back into there, click, click, click. See if I can go into another theme. Sometimes it's a bit clunky to find things. Monitoring it from space. So you can go, I think I've got fire ones, wildfires. Let's have a look at wildfires. Don't think there's any wildfires in Italy at the moment. There might be, who knows? I think there are some in, let's click on another cloud. You can actually tell it to look for clouds. So there, for example, is a one with looking at fires, for example, and these indices they use is a burned area index. I should probably look for somewhere that's got some fires. Oh, looks like there's some fires on at the moment. And it uses the different wave bands and these indices, and you can go into more information there. And there's the false color and all that sort of stuff. So it's actually really, really the sort of stuff you do. You can look at burned area detection. You can actually pretty much do this for any part, anywhere in the world, and you can look at different dates. So if you look, for example, at 2017, and I sort of go into Australia, let's just go this way rather than putting up our thing, and you looked there, let's just look around our study area. So you can use any of these if you wanted to for your thing. I've given you some information, but there's nothing stopping you getting other ones. And let's look at August, September 2017, not 2019. Let's have a look at the burnt area index here, and we can just see, because it was very burning, you can see it's still burning. Oh, there's Hinds Dam. Ooh, okay, lovely. Well, that's so cool. I've only just discovered this one. And there's our study area. So you can see there's the normalized burn ratio. Oh, that's such fun. Ooh, I know it's bad, but it's also fun. Okay, so there we, for example, that's using this. Oh, I should have given you these ones, but you can also, as we said in last week's online workshop. You can use these. You can use any of the satellite imagery if you want. So this is where, oh, wildfires. Let's have a look at this. Oh, that's really cool. This is actually quite new in Sentinel. So so there, for example, you can see the fire still burning there in Binnaburra. Oh, wow, it's so cool. I mean, it's bad, but it's cool. Okay. Anyway, so yeah, anyway. And if you click on these, you can actually look at the different, I'm getting distracted. Sorry, I love to discover new data. It's just like incredibly, awesomely cool, but bad. Okay, so let's just go back into my presentation. Okay, cool. So a spectral index, and that's what I showed you in Copernicus there. It emphasizes a specific phenomena, such as a tree species, in an image, and sometimes also minimizes other factors that make the phenomenon harder to identify, like variations in soil. If you want to explore some of the Copernicus things, I gave you the link in my last in the online thing, but I'll just chuck the link into the chat just so you can. There's like so much stuff here, and it's just like so cool if you're interested in this sort of stuff, which is like my new passion. Which is very bad because then I bother everyone all the time with it. So a spectral index mathematically combines the spectral reflectance value of two or more wavelengths called bands from a multi-band image. So for example, in ArcGIS Pro, and I'm not doing this in the assignment because it's a bit more advanced, but if I click on this image here, and I go in here, just sort of zoom in, this is one of the ones I gave you, and I can go into the raster layer. You can actually, one of them, data somewhere, can't remember where, somewhere on it, imagery, it's hidden. There's different spectral indices that you can actually do, and you've got all these different ones. So there's the NBR with the fire, but if you click on it, it actually expects you to put which are the near infrared. And the way to get near infrared band thing, if you want to get that sort of stuff, let me just find something on the online, is you can sort of get, so if I wanted to download this image, for example, for this area, and if I log in, this is a free account, anyone can do so, just say I want to download an image, you can actually do the different bands and the raw data there. And you can download the specific bands, and you can download it as, I normally do TIFF 16-bit high quality, and you can see that there's just the standard Mercator projection there. So you can actually download the individual bands, but you need an account to do so. It's free, so it doesn't matter. And you can draw your, oh, it's such fun. Okay, sorry, excuse me. Okay, cool. So you can actually, and that uses, if you look at ArcGIS Pro, but you would need to do that. You also, so you can download the individual bands, but what you can also do is, I'll put it into the link if any of you is really passionate about this, is, where is it hiding? This is the actual part of Copernicus where is the browser is more of a visualization thing, but the Open Hub is where you can actually download for a whole area the individual thing, which is actually an XML data, and then you can add it to ArcGIS. I'll chuck him into the bar in case anyone wants to play around with this sort of stuff. Okay, so this is where you actually you can use the same account for all of it. Where am I in my PowerPoint? And then you can calculate the spectral index in, oh my God, I've opened so many things up now. I don't know where I am. Let's find my ArcGIS Pro. I can see it up there in my alt tabbing. Okay, so, you know, there's the different spectral indices that you can do on the raster layer. Where is it? So there's the different ones you can do, and you can also create your own custom index, which I don't really know how to do. I think I did a couple of simple ones, but they're actually quite complicated. But if you click on any of these, you can actually say, for example, the burnt area index, and you go on the more info, it will then open up a whole thing, normally, or hopefully not linking to GitHub, probably. And you can look at it in Sentinel Playground. That's another one. And you can describe the script, or you can go into the script it does. So let's, yeah, of course, it's in GitHub. And there's all the different stuff if any of you are good on GitHub. I find GitHub quite confusing. And you can actually download the script itself. You can look at the code, and you can download the zip, etc. if you know how to use GitHub. I do know how to use it, but I find it a bit clunky because I'm not that good. And you can evaluate and visualize the script if you go in there. One of those, a general description of the script and a description of the representative images. So it's really, and you can show the script. So if you're into sort of scripting, what language is it done? I don't know. I think it's a specific script. It's pretty easy if you can figure out what it says. It just says make the color there, make the color there, and put in the different bands. You can see the calculation there. The index is, that's the index they've created. And in fact, Copernicus has got, if you're interested, they've got a custom script competition on at the moment. It might be. New viewers interested in this. Okay, I'm getting distracted. But anyway, but this is a sort of way that you can actually use remote sensing to really cool things. I'm nearly finished, so that's why I'm sort of getting distracted onto this. And as you can tell, Sentinel Hub, there we go. If you're interested in this sort of scripting, you can. Our hub climate change. Oh, lovely, lovely, lovely. If I was any good at this, I'd enter it, but I'm not. Okay, and there's all some of the custom script visualizations. Oh my God, this is like so awesomely cool. Okay, anyway, so apart from it's so awesomely cool and incredibly awesome, and I have way too much work to do that sort of stuff. Okay. Cool. So anyway, mathematically combines the spectral reflectance value of 2 or more wavelengths. So you could see there's like a very simple equation in there on the burnt index. That's the pretty simple equation to me. That's the index and that's the minimum, and it's got the sort of like the what's it called in scripting? Can't remember what it's called in scripting. It just tells you what it's about. Scripting for ages. Yes, I have. Don't lie, Heather. Okay, so there's one they use as the normalized difference vegetation index, but you can use spectral indices to evaluate vegetation health, identify burns, and in fact, if we ever, if the hierarchy, Chris is actually, I think, going to be teaching a specific remote sensing course from next year. I must find out. So he will be teaching this sort of stuff, and hopefully we will do an advanced GIS course where you can teach all this sort of really cool stuff. Some sort of postgrad. And index can be used for visualization, or maybe a really sort of intense one over T3. Oh, such fun. Okay, in which case the values are symbolized. So if you see there on this index back there, if I go back into the browser, the values are actually symbolized. So it's symbolized from -6. Let's find somewhere that was actually burnt, from -6 to thing, and the symbology, let's have a look here. There's the burnt area detection. Oh my God, this is so cool. So that's like symbolized. Oh, that's just burnt or not. The normalized burn ratio. Oh my God, that's even cooler. You can see there how it's symbolized. Anyway, it's so cool. Anyway, so let's go back to the presentation, which is nearly finished anyway. And they also used as analysis with the raw index values as input. So you can detect change in vegetation health. And one thing that they do, a research project I found quite recently, is they looked at time series of Sentinel-2 to estimate tree cover change over a long period of time. Of course, the results were terrible and the tree cover change had diminished horribly because that's what humans do. Anyway, cool. So anyway, spectral indices are really cool. And there's a way there. Oh, look. So this is one, if you can see the rasters there. Now, these are the multispectral ones, which are actually taken from that, the main Sci-Hub Copernicus. And if you do the drop down, there's actually quite a lot of different things. And the spectral indices are actually there. So that's just one of the ones I was doing. It was sort of T3, but it was another project I was just doing myself for fun, because some people do that sort of stuff for fun. Okay, so calculating spectral indices. So Pro can do it for you if you know the spectral indices you want to do. You also have to know the bands for the image that you have. So there's Sentinel-2 on the right, and it's important this because I'm going to ask you this in the mini quizzes. And you can also combine the bands, and now you can add them, or you can subtract them, or you can multiply them, or you can divide them by one another. And we use band combinations to better understand features in imagery, because the imagery is collecting data from all parts of the electromagnetic spectrum, and we can use that to sort of identify what are the tree types, how dense are the trees, how healthy is the vegetation, where's burnt, has it recovered. And there's specific band combinations that highlight geologic, agricultural, or vegetation features in an image. And you can check out Sentinel Playground, which wasn't actually in last week's workshop. Did I do it in last week's workshop? Anyway, it's one of the different ones that you can do. And it visualizes the band combinations below. So you can play around in that EO browser or any of them. You can change band combinations. And you can see there, look, there's the wavelength, there's the resolution. So the ones that you can actually see, blue, red, green, blue, are 10 meters. So they're quite, whereas some of them, the shortwave internet is 60 meters, for example. And there's like, this is Sentinel-2 band. So it's the blue, green, and near infrared have 10 meter, and then it's red edge, shortwave internet. I'm falling off my words today. Anyway, so there we go. And because I'm excited, and coastal aerosol, I'm always excited. So this is some of the ones that you might look. So for example, there's the natural color. I've given you some natural color. There's the color infrared. There's one that detects agriculture quite well, and there's a vegetation index. There's also ones that specifically do urban. Now I find them the too higher resolution, too smaller resolution. I always mix up, but there's a really good neural deep learning libraries to do that sort of stuff, or else you can try and get OpenStreetMap data to not crash your computer. Okay, cool. But apart from that, that's not actually satellite imagery. And there's, you can calculate spectral images yourself, and you can go into, so if I go into EO browser, for example, which is, it's so cool, you can go into custom, and then you can add all the different things. So you can add on to, I don't know, let's just randomly add some things, chuck on, I have no idea what we're doing. And we'll chuck some green there, and you can actually create an index. I don't think this actually means anything, because I'm just sort of randomly putting, I can take B12 off and put B4A, and you can create your indices. This would be a very simple index. That's a really terrible color. Okay. Anyway, so like you can do all that sort of stuff yourself. So it's quite fun, particularly if you know what you're doing. There, for example, that's the NDVI, which is the vegetation. And this is like the fire area. I don't find the NDVI very useful. And you can put all sorts of stuff. If I put the true color onto that area, don't forget I'm looking at the fires. The true color, as you can see, is horribly dry there. Let me go back into my PowerPoint. So it does take a bit of knowledge. So remember, garbage in, garbage out. Now, if you have no idea what you're doing, like me, what I was just doing, and then you can also write those scripts. So, for example, you can go back into that. And when you're doing your custom script, you can drag them in. But what you can do is you can actually write your script. It's a very simple scripting language. And you can, there's the index, and there's the equation. So you can actually create an equation. You can add all sorts of different things. Oh man, that's so cool. I have no idea what it means. It doesn't mean anything. But anyway, you can see burnt area quite well in that one. And I could make a script. Sorry. I know it's time, and we'll just pop that in. Let's see what that happens. That's boring. Oh my God, that's so cool. Okay, we'll chuck that in. And you can see a custom script. And that is complete and utter gibberish. Okay. Remember, garbage in, garbage out. Okay, let's see what happens there. Oh, that doesn't matter. And it's horrendously ghastly. We'll put the burnt area index back on. Okay, where am I? I got distracted. Okay, cool. So you can create your own script, especially if you know what you're doing. And we will go there. So there we go. For example, there is just some false color composite of an area. And there is a natural color. And there's some script examples, and I think that's from last year's custom script thing. And there, for example, there's a pseudo forest canopy, wildfire visualization, burnt area index, and homage to Mondrian, which was just fun, but doesn't really mean anything. What might? Anyway, so you can use these scripts, and you can use these remote sensing, even just using that EO browser, to find all sorts of incredibly awesomely cool things. And the actual scripting you do is pretty easy, but you have to sort of know a bit about the electromagnetic spectrum and what you're trying to look for. And when they do these projects, you'll tend to find that they use a number of different scripting things. They overlay that, and then they use more complicated algorithms and equations to actually find out what it's supposed to be. So if you go into it, it's really interesting. And yeah, okay, it's probably a bit advanced, but I just wanted to show you some of the sort of stuff that you can do with remote sensing. It's incredibly fun and awesome, and it's like more and more stuff that you can actually do. Cool. Okay. So the reason I'm sort of showing you things like this is because this is the sort of stuff that you would do in this sort of analysis, and the sort of stuff that it can actually do. Where's my stupid Teams? I've lost it. Okay. Where's the stupid Teams? I've lost it. Okay. Don't open too many things. Anyway, so that's just some sort of idea, just to show you a case study of what can be done in remote sensing. In fact, week 12 or week 11. Week 11, I'm going to do sort of like future of GIS thing, which I'm going to redo from last week because there's more and more stuff. Last year, there's more and more stuff that's been done since. Anyway, so I will see some of you in the online thing. It'll be uploaded afterwards. And just remember that the online thing sort of tells you step by step. The in-person ones, you know, there's obviously me and the different teaching assistants who can actually help you with individual things. But all I say, thank you very much for attending today. And yeah, stay well. And I will see some of you later and some of you in class. And cool. Thanks very much. I'm getting around to marking all your assignments. I haven't even started yet because I'm sort of fixing up the rubrics, but there's a lot of them. So it's not going to, yeah, it's not going to be that quick. Hopefully by the end of the week. Okay, thank you very much. Okay, bye. Well, I may hope to finish by the end of the week and then I'll send it off to Chris and the teaching assistants to have a look and then I'll finally do it. Thanks very much, everyone. I'm going to stop recording if I can find where it is.